All right, well, welcome everyone to our weekly Wednesday webinar series. And thanks to our session sponsor, Mitsubishi Electric. Mitsubishi provides all your heating, cooling, and filtration needs in one system. Today's low-load homes require right-size equipment that most systems, especially gas, cannot meet. Mitsubishi has low-load, high-efficient heat pumps that dehumidify and cool in the summer and work in reverse to heat in the winter. Going ductless reduces costs and makes it easier to meet the ENERGY STAR version 3 and LEED for Home certification. Ductless mini splits can now be hidden in many different ways to meet your client's needs, and ducted systems can now be used as well as ducted mini split systems. Ducted systems are hidden behind the walls to ensure beautiful space and can be retrofitted into the place of a furnace for an existing single or multi-family project. Speaking of hidden heating, Mitsubishi scores the Green Builder Sustainability Award for 2019 for their MLZ one-way ceiling cassette. Check it out in their January and February article. And for those of you living in very cold places, the Hyperheat ensures efficient heating down to -13 degrees. Each room of a house can be customized comfort, still being all electric and energy efficient. And in multifamily and commercial systems, variable refrigerant systems are efficient and work great on large projects to serve whole buildings, or can be coupled with heat recovery technology to simultaneously heat and cool. Check them out at Mitsubishi Comfort. And thanks to our second sponsor, Panasonic, your #1 source for ventilation for new and existing homes. Panasonic has a wide array of systems to choose from to meet all your supply, exhaust only and balanced. They have the IntelliBalance for ducted or decentralized ERVs, and they also picked up a sustainability award from Green Builder Media for their Whisper Fresh Select Fresh Air Supply Fan, as well as Green Builder's Reader Choice Award in 2019. Pair the Select Cycler with the Whisper Green to get an affordable balanced air solution, and that can be coupled with a range hood pressure sensor to ensure you have the appropriate flow on larger volume rain hoods. Check that out over at Panasonic.com. All right, well, welcome to the basics of HVAC sizing and low-load homes. This course is approved for 1 hour in continuing education units, especially LEED AP homes, BPI NonWholeHouse, and many more, as well as AIA Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. And our course is approved by the Passive House Institute US today. I'll be your moderator. My name is Brett Little, and I am the executive director here at the nonprofit, the GreenHome Institute. And today we're going to just be talking about how spaces are getting tighter and tighter and more efficient as codes progress, and how the nature of our changing HVAC sizing systems need to move along with that. So with that, I'm really excited to introduce our speaker, Wes Davis. Wes serves as the Vice President of ACCA, or ACCA, Quality Assurance Program, supervising contractor accreditation efforts, recognizing quality of contractors and HVAC system quality installation. He has over 20 years of experience in the HVAC industry, and he has been a licensed HVAC contractor in South Carolina, serves on many ASHRAE technical committees, wrote Bob's House, serves on ResNet's Standards Management Board, and has helped develop several ANSI recognized standards. So with that, I will hand it over to you, Wes, and then also just know everybody, we'd love to have you join our conversation throughout today's session.
Oh, great. Thanks for having me, Brad. I appreciate that. To start things off, I'd like to cover a new product we've got that's just come out. Our new manual LLH, or for low load homes, and across the bottom of the cover of the manual, you'll see several other ACCA manuals and guides, and this is a collection of wisdom and input for those or from those standards. It's coalesced here, along with some new content that we think will be helpful. So the first question is, what's a low load home? And for a lot of forward-thinking people, that means, a very tight home. It's very well insulated. A lot of good construction products went into the manufacture of that home. It's using high efficiency appliances, and that is certainly a big target market for this standard, or this, excuse me, not standard, this manual, because there are some problems associated with sort of typical sized homes that have very small loads, and this standard does a great job of speaking to that, primarily around the air mixing issue. But there are also homes, and they could be large or small, that are just in a very mild climate, say for example Hawaii or maybe Seattle. So if it may be a leaky home, maybe not that well insulated, but it has a low load, and so we don't want to confuse those two things. Similarly, there are condominiums or townhomes or apartments, other dwellings that just have a small footprint, but they all fall in to this category of a low load home. And this manual addresses equipment selection, air distribution issues that need to be addressed. So when we think of a low load home, what does that mean? In the upper left hand corner, you see a image of Manual J, ACCA's standard for calculating the heat loss and heat gain that a domicile has, a dwelling has, and that depends on where you're located in the country. It depends on the windows. If you've got a lot of windows, and that's a big factor, it may be that you've got a lot of windows that are all facing north, and so that's not as big a factor. How much insulation's in the house, and does it contribute to a tight dwelling or not? Same thing for the walls, doors, appliances, how many occupants are in the home. And a lot of people model their homes with lots of occupants, and that's not quite right. Ventilation becoming much more prevalent. Infiltration has to be factored in, of course. Duct losses also need to be considered when determining how much heat your dwelling is gaining or losing throughout the year. So all those factors ultimately boil down to what size unit do I need to install. And so for a home that was it's about 3,000 square feet, for example, nice dwelling, in the old days that might have been a 5-ton unit, and that'd have been acceptable, been perfectly sized, no problem. But today, that same 3,000 square foot house might need a 2-ton system. And so if you're sizing HVAC equipment based on old rules of thumb or old assumptions, you can get yourself in a world of hurt, because the equipment's not going to perform or interact with the dwelling the way the old systems did. One of the things that Brett and I were discussing getting ready for this was, what are some things that you could verify when it comes time to evaluate the HVAC system sizing? And the basis for that is the Manual J load calculation. This is an eye chart. We're not going to stay here too long. I just wanted to touch on briefly, number one, the fact I'm using the J1 form in worksheet A, and those are standard forms from Manual J. There are a lot of other software products out there that produce a wide variety of reports. The information that we're going to discuss today should be available on those reports. You can have your contractor point out where that is and ask some questions along the way. And so again, here's a list of some things that could be checked, and we're going to dive into that in a little more detail. The first thing is the location. The primary reason for that is this drives a lot of the design, or one big contributing factor of the design, and that is the temperature associated with where you live. And so you may want to dial in and look at the report. Does it show your specific address? Does it say 123 Elm Street? Or at the very least, have we got the city and state right? These are using Manual J or ASHRAE weather stations. So it might be that you live in a suburb, and it may show like a larger metropolitan area. Say instead of Frisco, Texas, it might show Dallas, maybe even Denton. But you need to make sure that what's represented is representative of where you live. As I mentioned, design conditions, there are, what were the design conditions that were used, both indoor, so here I've got a cooling design condition of 75 and a heating design condition of 70 degrees, as well as the outdoor. So 99% of the time, it's going to be 2 degrees, minus 2 degrees Fahrenheit, or warmer. And 1% of the time, it's going to be 95 degrees or cooler. And those two values are very important. They need to comply with what's prescribed in Manual J, as well as the humidity that's in the area. So this is a very specific value. Relative humidity is just that, it's very relative, it changes. But the grains difference between what's going on in Beatrice, Nebraska in the summertime during the peak cooling day and what's going on in your house, 75 degrees, 50% relative humidity as a target, is represented in the grains of difference. Another thing you can check very easily is the floor area. On the Manual J1 form, if your house isn't 56 by 32 or about 1,800 square feet, then you may want to ask your HVAC system designer what they're using as the basis. And it's understood there may be some architectural details and it's represented in a very rough 56 by 32, but it needs to represent what the floor plan, the footprint for your home. Window area and orientation. So these are heat transfer multipliers, but the area of different windows in your home should add up to what your home's window area looks like. Skylights, same thing. If your house doesn't have about 40 square feet of skylights, then that may not be your house. So check that to ensure that your home is the one that's being properly represented. Next, we look at a couple of other big ticket items. One of those is infiltration. And on the J1 form that's found right here, the important thing to note is this is the heating column, and these two columns are cooling capacity related. This is sensible, this is latent. This has to do with what you would see on a thermometer or your thermostat. This is hidden heat that's in the form of humidity, but it still needs to be accounted for. So infiltration, you can see that 1/6 of the load for this home is in infiltration. So if you've got a tight home, ensure that that number is not that high. Same thing for cooling. The latent load, 30% of the latent load is from air that's going to transfer in and out of the house just due to wind, the force of wind, and how leaky the home is. Occupants, yeah, go ahead.
Wes, and just, yeah, I think you just said it before I said, but infiltration is just another term for like air loss or air leakage, correct?
Yes, that's what it is. Yep. So the other item, occupants, if you've got a 3-bedroom house, it should be number of occupants plus 1. And then you can see that that contributes to the cooling load. Appliances, this is scenario number 1. This is a standard default value, typical for say a 3,000 square foot house. 24,000 BTUs were added to the house. If that number is different, it may be justifiable. But that number should either be 1,200 or 2,400. I think I said 12,000. 1,200 or 2,400 BTUs. If they're using something else, and it may be completely justifiable. Hey, you've got a lot of audio visual equipment. You've got a home theater that has a lot of heat generating equipment. That could be a function of that. It needs to also, as I said, be justifiable. I don't know if you stay in your media room for hours on end, or if it's, once a day for some brief periods of time, or maybe on the weekend. So if it's an intermittent load, that needs to be factored in. Duct loads, if your ducts are in the conditioned space, then these loads should be 0. Again, these contribute pretty mightily to the totals for the home's heating and cooling requirements. And last but not least, ventilation. Look, is this the design ventilation that you were expecting? And if you want to dig into the weeds, then we can get into the calculations for that as well. But those are some very quick, easy things that you as an owner or someone that's reviewing the system or the design, the HVAC system design, this first step, manual J, heat loss, heat gain calculations. Is this what properly represents my home? Brett? So I think the next part is Brett and I were going to have some interaction back and forth. He had some questions. I thought that would be a little more informative than just me droning on and on.
Yeah, thanks. I was stuck on mute there. So I wanted to just talk about sort of the interplay or the conversation, especially on the early design stage, between the designer, architect, and HVAC design, as there's kind of iterative processes, right, where the design changes, and just, is it relatively easy for HVAC to, on the design side, adjust these, if things update within that design before construction starts?
Sure. So, as soon as you have your design finalized, and we all know that things can change, that's when I would hand it off to the HVAC contractor. And it may be that things are still in flux, but the builder or the owner would like to get a rough idea of what it's going to take for the heating and cooling. And so the contractor needs some basis to base their estimate on and for equipment size. So if they get the plans at an early stage and there are modifications made, maybe windows are added or removed, or window areas change, or window attributes change, the efficiency of that window changes, that's when that needs to be passed along. And it's relatively easy to go into the software, apply a change, say we're going to remove a window, or we're going to add a window, or we're not using brand X windows anymore, we're using brand Y, and they have different U values or different solar heat gain coefficients. That information needs to be passed along so that can be factored in to their calculation. Now, to the extent that I'm just changing from brand X to brand Y, and it's the same size window, and it's the same U value, and it's the same solar heat gain coefficient, that wouldn't need to be passed along. But if we're adding or removing or increasing the size or decreasing the size, or again changing those component values, then that needs to be passed along at the, I was going to say at the earliest opportunity. I think once the decision's made, if all right, this is the final, this is what we're going to go to construction with, that's when I would pass that along. And to the extent that there's an impact on the load and the equipment size went up or down, then that could be reflected in their proposal.
And I'm just looking at the like the windows here, skylights, and I'm wondering a little bit, like if you were just trying to check like those U value examples and making sure they, hit the load calc correctly, and you're reading this, how would you, how would you be able to do that? Or is it really just more getting, the designer on the phone and saying, hey, can you just double check that this is the correct U value, for example?
Right. Yeah, that's fairly low in the weeds. If we're at that stage, then I'm thinking that on the next page, down at the bottom, when you see the total heating and the total cooling load, and you think, holy cow, I was expecting something a lot lower, then you can go back and maybe look at some of the big load items like infiltration or like ventilation, if you're, and or windows. So yeah, you could drill down into those aspects.
Okay.
And I can get into the weeds. The heat transfer multiplier is essentially a function of the temperature difference and the U value of the window.
Oh, that on that last slide, you're saying the
right
over here. Yeah.
Yeah, there's some other But yeah, if you want to delve into the actual U values and that were used, or the solar heat gain coefficient aspects that were used, you could talk to the contractor about that.
All right. And I'm just looking at some of the questions that came in here, and can you address the importance of having the room by room manual J done versus the whole house?
Sure. So I think that for equipment sizing, let's go back to the example of, you know, we've got the design to a certain stage, and I need an estimate. It might be that the floor plan is finalized enough that I could do what's called a block load. So I'm just looking at the whole house as one big load. And from that, I may determine, you know what, I've got an upstairs and downstairs. It might make sense to go with 2 systems. This is a conversation that can be had, or maybe it's a requirement that can be specified. But at the end of the day, I'm looking at huge sections of the home, and that's very good for helping establish equipment sizing. When it comes time to install the system, then room by room loads are invaluable, because it's only when you examine the loads in one room that you can determine how much air to dump into that room in support of how many BTUs it needs to stay warm or stay cool. So, you know, for comfort in the home, room by room is the only way to go to get a rough estimate for equipment sizing. A block load is perfect.
Great. So, you know, just helping some folks out with some of the terms that come up when you're looking at these calculations. Can you just kind of take us through what they're going to see, what those mean, and kind of how they compare, contrast, or translate?
Sure. So the first term, K BTUs per hour, is 1,000 BTUs, or British thermal units, that are used or need to be provided during an hour's time frame. That's what we use a lot of time in the heating and cooling business. And that same term is presented again in a different format right below it, KBTUH, and then right below that, MBH is M is 1,000, B is BTUs, and H is an hour. So those first 3 terms synonymous. The bottom term, tonnage, comes from the old days when we take a chunk of ice and use that to provide cooling or refrigeration. And this is representative of about 12,000 BTUs per hour. So a 5-ton system would be 5 times 12, 60, about 60,000 BTUs per hour. And in the cooling mode, that's heat that's extracted, and in the cooling, in the cooling mode, it's heat that's extracted. In the heating mode, that's heat we need to add back to the space.
So just about for the tonnage, it's a conversions of these top 3. The top 3 are the same, and then the tonnage conversion is about 12,000 of these to 1, right?
That's it. Yep.
Yeah. So the next thing I wanted to take a look at here are you know, really some of the alternative tools out there that try to project sizing, if you will. And the reality, a lot of these low load projects are typically using HERS index ratings through energy ratings, and there is a report within REM, and I believe Ecotrope and the other softwares that typically produce or attempt to gauge heating and cooling loads. So can you speak to a little bit about sort of these alternative softwares that try to attempt to guess that, and you know, whether they're accurate or how they approach it differently?
Sure, and that's a great question. And the short answer is I really would need to study this a bit more. I've reached out to a software platform that is both approved by ResNet, to comply with standard 301, calculate the energy rating index, and they've also submitted their software to ACCA to be reviewed for compliance to Manual J. And I hadn't heard back from them, but if I were going to guess, I think that the difference, if there is a difference between the values, if compared to say a Manual J value, might be either slight nuances in how a building component is modeled, probably a very small amount. I'm thinking it might have more to do if we've got sort of apples to apples regarding window area, floor area, building component, characteristics, etc. Might be in the temperature difference that's used. So Manual J is looking at a peak condition on a hot summer afternoon or a very cold winter morning. And for energy rating, I believe they may be looking at just when am I using the most power, and what's the load associated with that time of day. So, or month of the year or time of the year. But that's going to be my best guess at this point.
What about, so there's a question here about the Passive House Institute US, because we're going to talk briefly about that in a little bit, but the PHIUS software and just having some discrepancies to the Manual J load calcs. Do you know anything about that particularly, or would you kind of have the same response to that as you do with REMRATE?
Yeah, I apologize. I do have the same response I would have to REMRATE or Ecotrope or Energy Gauge or any other resident approved software. I've not examined it to know how closely it complies with the Manual J process or the results that might come from that.
Speaking of software, but getting more into the Manual J focus, just one particular comment was somebody noticed that software was being used was Elite or RightSoft. Is there any preference or I guess difference between the two from your perspective?
Good question, and the answer is no difference from our perspective. They've both been recognized as approved software platforms by ACCA. If you go to accca.org, one of the areas there is codes and standards, technical information, and we've got a list of approved software. So if you want to know, and that's our criteria, is the software approved by, has it been submitted for review? Have we compared the results from their calculations with what we would expect from Manual J? And so that's where the list of software is, and regarding RightSoft and Elite, both listed as approved, powered by Manual J software.
There was some more follow-up here, and maybe they just kind of jumped in a little bit late, but just I guess re-honing in on that on that value of room by room versus whole house, and maybe just I don't know if you had anything more to add to that.
No, for zoning purposes, if you don't know the loads of each room, then it's very difficult. That may be one area that I didn't touch on earlier, but block load is fine for equipment selection, but for occupant comfort and for maximizing the performance of the system to deliver BTUs where they're needed, a room by room heat loss, heat gain calculation needs to be done so that you know the target you're trying to reach for that space.
Yeah, great. Is there any kind of software out there that obviously before you're kind of just in that design stage as a designer or architect, and you want to sort of kind of gauge where your project is kind of coming in at, before you bring in HVAC design. Is there anything out there that you recommend as a decent starting place for that?
I don't. I'm not quite sure where that question's going, but if we're trying to determine or trying to approximate what the load is, I mean, there's I just prefer to use a ACA manual J.
Yeah, no, that makes sense if you want to get it right. That's fine. And then, on that note too, I don't know if you have any numbers or just kind of anecdotal on that, but I mean, what in reality, what percent of your conventional project before HVAC is installed, whether it be new or existing, do you think is getting a formal manual J done?
Oh wow. I think more and more. I couldn't give you a definitive number or even a percentage, but I believe because it is a more widely accepted practice due to code adoption. I think it's a more widely accepted practice due to the realization that homes are performing differently. And so if I use the same old practices, there are consequences. Here in the Northeast, or at least the East Coast, last year we had a very moist summer. We had a lot of rain, and there were a lot of homes that had a lot of humidity issues. And some of that was due to the excessive amount of rain we got. Sometimes that's just the tipping point, but I think that what we saw here in Virginia last year is indicative of how things might progress if we're using the same old practices on new construction types and the new benefits that we're getting from better windows, tighter envelopes, more insulation, ventilation. If that isn't addressed, then we're going to see some real humidity issues start to crop up. And so I think that the value of digging in, tightening up how much heating and cooling a home needs is, I think the value proposition is growing.
And you mentioned code, and is there a particular IECC year that requires, and I know when states adopt it, they can knock it out or keep it in anything they want, but is there a particular IECC year that where manual J or sizing becomes required?
I know it's kind of out of sequence, but I believe it was like 2000. It was either 1999, 2000, right in there was the first reference, the first requirement for manual J.
Okay,
and that was in the IECC, not the IRC. But
so essentially, any unless the state doesn't have a code, I think most now are at least 2004. So it should, unless they took it out, it should already be in there then, right?
For IECC, yes.
Yep. Okay.
Yeah, if there was an exception for some reason, right, couldn't speak to that.
Mm-hmm. So here's a question that kind of comes in on the low load home side. Are there any different algorithms that need to be applied for low load homes, or does manual J cover all homes equally well?
Good question, and the short answer is manual J. And this was a discussion during the drafting of the low load homes manual. A lot of time was spent looking at different building programs like Energy Star or DOE's NetZero Ready or NetZero Energy Homes. What characteristics do we need to have in this home to create a load small enough to be classified or to qualify as a low load? And in the end, we just said, you know, it depends. But at the end of the day, we need to have a strategy to deal with these homes that do have these low loads. And we have a proxy number of about 1,500 square foot per ton. So if I've got a 3,000 square foot house and it's got about 24,000 BTUs or 2 tons of cooling, then that's what we would quantify or look as an example of a low load home. I don't know if did that answer the question? Is that so Manual J just says, well, what kind of wall are you putting in? Well, I'm putting in a 2x6 offset framing with R60 in the wall, and I've got R90 in the ceiling, and the ducts are all inside, and I've got an insulated slab. Whatever the construction components are, triple pane windows, whatever those elements are that bring you down into that realm of about 1,500 square foot per ton, or I believe it's 15,000 BTUs per square foot, then that's what we're calling a low load home.
Yeah. Yep. Okay. No. If there's more follow up, they can respond
Sure.
more. So here's just a little more. You know, their concern was about block load not sufficing for sizing mini splits with multiple indoor heads, or even for sizing supply duct runs to various rooms. And they said, in assuming an even distribution of heat loss gain by square footage will lead to the creation of hot and cold rooms. So there's mentioning something about rectangular floor plan, rooms at the ends of the rectangle can be exposed to 3 outdoor walls versus rooms in the middle with exposure to 1 or 2 outdoor walls. So kind of just getting into the various design aspects. But any other response to that from a sizing standpoint?
Yeah, that's a very good question. Very interesting. And I think I'd like to try and take that piece by piece. So if I have a block load for a house and it's, for example, 30,000 BTUs. Let's make it a little more. Let's make it 27,000 BTUs. If I'm then going to put in a mini or a multi-split product, it might be that product's capacity far exceeds that 27,000 BTUs. If I'm putting in a standard central air system, that falls in the sweet spot for a 2.5 ton, about 30,000 BTUs of cooling, and depending on the location, if I'm in Duluth, that's going to be a whole lot different than if I'm in Miami. But the heating requirements will be reflected there. But I think that the multi-split or the mini-split solution set adds a new wrinkle, and Manual S, which talks about equipment sizing capacity or equipment sizing tolerances, has some, I think, pretty generous allowances for oversizing variable refrigerant flow or variable speed systems, especially if we know what that capacity is for that system. So if I've got a system that's a nominal 2.5 ton, or maybe it's a nominal 3 ton, but because of the VRF capacity, I can scale that down, or I can unload capacity, then that changes things slightly. Manual LLH adds an additional factor, and that is if I've got supplemental dehumidification, then I've got a little more buffer for single speed systems. It creates and that's one of the problems we're trying to solve, right? If I have cooling equipment that's far too big, then it's going to short cycle, which is hard on the equipment. It's not going to have nice, even temperatures distributed throughout the house, typically, and not going to get a cold coil, so I won't dehumidify. So if I'm in a pretty humid environment, then I'm not going to get the benefit of having that cold coil and the moisture removed. So that's the reason we have the sizing tolerances set where we do, to try and promote the best of comfort, dealing with both what's on the thermometer, the sensible load, but also removing moisture in humid climates. So when we're dealing with multi-splits, if there's some supplemental dehumidification there, then I think that the tolerances are expanded. And what was the next part of the question, Brett? Dealing with room to room, rectangular.
Yeah, I think it's really just, I mean, it gets very specific here, but having rooms being located in the middle versus on the exterior, sure. And then just, right. Different shapes as well. So
exactly, and really, I must not have explained it well, but I think that's exactly the reason you need that room by room heat loss, heat gain calculations. If I've got a powder room in the middle of the house, the load is negligible, even if it's a large room. I've got conditioned space all around it. It may be on the first floor, and there may be conditioned space above it. So it's got no load, really, as opposed to a corner bedroom with a lot of glass and 2 exposures, or I think in the example that was read, there's 3 exposures. And so if there's some architectural details and like that, then absolutely that room needs special consideration, as do all rooms. But you don't know what you don't know until you do the math, until you calculate the loads.
So here a question about moving forward, and I think it speaks really to resiliency and adaptability. How will Manual J, if at all, plan to address the changing of the climate in reality? I mean, if things get hotter or colder or drier or wetter, being able to consider that in the future.
Right, and that's a great question. I know that there's a committee at ASHRAE that spends their time on this very subject. I will tell you that it's a tough nut to crack. We're all looking in our crystal ball, and some see one thing, others see something completely different. I'm not going to disparage any camp that says, oh, I think it's getting warmer, or I think it's getting cooler. And so Manual J is in a tough spot. The good news is, if you've ever done the heat loss, heat gain calculations, if you do play with that temperature, and you say, okay, I'm going to use a design temperature of, instead of 92, I'm going to use 93 or 94. I'm going to simulate that global warming, or that climate change to a warmer climate. The impact on the load is typically, especially in low load homes, is not great. It's not large. And that may be a conversation you want to have with your customer. I think that anytime you start deviating from the standard, you expose yourself to liability. And so if you pick a design temperature that's different, you need to be able to justify that, because it could have ramifications on equipment capacity and performance. So that's, but you're right, that's a tough question.
So I'm glad you said that, and tell me if my line of thinking here is way off, but I'm envisioning, you do your conventional Manual J and you do the real one and you size for it, but then you might say, let's run an alternative one on this project, and say, like, let's say I live in a city like Grand Rapids. We have a sort of a climate resiliency plan where we try to forecast, increased temperatures in Michigan here. And you said, well, what if I'm looking at that thing and it says in like 15 years, this will be the new average temperature, and you kind of created a secondary calc and said, okay, what if it looks like this in 15 years? Where is this project at? Is that one potential way you could use the design tool just as a sort of experiment?
Well, sure.
Yeah, great.
I don't want to oversimplify it, but yeah.
Right. Yeah, no, the answer is yes, no, or I just want to make sure my line of thinking isn't off. And on that, I mean, do you think then modulating, might be a potential future solution to, guard against any kind of increases in the future?
Well, so again, yes, probably. If I'm right on the threshold, I used the example earlier of 27,000 BTUs as a cooling load, and if I increase the design temperature, and that puts the load, say, around 28 or 29,000 BTUs, I'm really outside, or I could potentially be outside the capacity of a 2.5 ton single stage system. And I might need to bump up to, say, a 3 ton, a larger system. If we're talking about a 15-year resiliency plan, we need to take a good hard look at whether that makes sense, because I've got a period of time before that really starts to impact the actual home itself. So if I make the change and the design temperature and the impact is small, or it still fits within the band or the capacity limits of that cooling system, then it's no problem. It's only when we're crossing over to the next size unit. And Manual S did modify the tolerances. You can have a system that's too small for cooling, and it'll run longer. If we're talking about a green home, or someone that's concerned about protecting natural resources and trying to reduce or at least minimize the impact on the grid, then a smaller system is going to perform extremely well, even when we start reaching the upper bounds. Because remember, Brett, we're talking about peak conditions, which happen for a few hours during the year. And sometimes there are years when we don't get close to those peak conditions. And there are times when we seem to hover. Every day seems to be something above where we, that peak design condition. So I'm very cautious to recommend or propose that people play with these excursions too much. I think it's good to know. I think it's good to be informed and be aware, but to apply something that might happen at some point in the future for a few hours during the course of a year, and apply that to a system I'm going to design and install today, has potential for problems.
Great, thanks. So these low load homes, and especially increasingly we're seeing multi-family buildings, apartments, with hyper low loads, even if they're not inherently designed other than just following the code, are coming in really low, and in cold weather climates and climates that have a lot more gas usage or natural gas, like from where I'm at, we're not necessarily able to find systems that are anywhere near what the heating load is telling us it should only be. Mm-hmm. And even if we get into dual stage and modulating, mm-hmm. We're still not finding it there too. But even we especially like at affordable housing projects, or there's a really tight budget. Mm-hmm. It's hard to justify those upfront costs, mm-hmm. on those kinds of systems. So what do you see out there? Do you see anything out there for opportunities to address that?
Well, help me understand the issue. When you're talking about small heating loads, what's small? What are you thinking about?
Yeah, I mean, we're seeing things come back in all the way down to like 4 MBH or 4 kBTU.
Sure.
So yeah,
and that's at the peak. That's at a cold February morning.
Right, exactly. Yep.
In the introduction, you mentioned one of the sponsors being able to provide heating down to -13. I think that heat pumps, when the load is that small, certainly ought to be given a look. There's supplemental heat with heat pumps. They typically electric heat, but for those very few times when you might need some assistance, I think heat pumps are a real possible solution for that scenario.
Great. And then keeping on that conversation, heat pump water heaters,
right?
They, from an energy standpoint, we kind of look at those, and if you're seeing all electric, you kind of see that they're going to drive up your heating costs, especially if they're not vented, and they're going to maybe help you on the cooling and dehumidification side of things. But if you have heat pump water heaters, do those currently have any impact on manual J?
Well, let me come a long way around the barn on this answer. A lot of different factors impact this. Number one, or I'll start at this point. I'm not going to call it number one, but I'll start here, and that is, when are we making hot water? Is it early in the morning? Are you an early shower, early morning or morning time shower person? Are you midday doing the laundry? Are you cooking and showering and cleaning or whatever in the evening? Because that heat pump water heater is primarily going to contribute to the additional heating need during those times. I think there are times when it may cycle just because it's got to keep the water warm. But the time when that system is energized and producing cold air plays into this equation. If it happens during the day, well, that's not the peak condition. If it's happening early morning, then that is contributing to the peak condition. I believe you mentioned the ducting kits. Some models have ducting kits, so that could take the cold air outside. There's some models that have efficiency settings, so it transfers back to your standard electric water heater, and so we're not producing cold air at 2 a.m., 3 a.m. On February morning. So for that and probably a few more reasons, Manual J does not speak to the loads associated with a heat pump water heater. We do talk about a wide variety of appliances, and as I mentioned earlier in the example, there are some default appliance loads that we apply to smaller and then larger homes, 1,200 or 2,400 BTUs. But we still need a little more information. One of the things we need is what's the actual heat transfer? How much heat would I need to add to the house to make up for that? I don't see a whole lot of performance data out, or I couldn't lay my hands on any. But if I'm taking 50 gallons of water from, say, 55 to 110 or 120, just some back of the envelope calculations, that's about 27,000 BTUs. So that's a lot. That's big. But if I'm taking that same 50 gallons from, say, 115 to 120, well, now I'm around 2,000 BTUs. So what's the number? And again, that's one of the reasons that Manual J has not incorporated a procedure to account for those loads at this time.
Does Manual J have a insert workaround? So like you said, if somebody tried to do a back of the hand calculation and really wanted to think it through, is there like a field that says, insert another variable that no one had thought of? Does that exist?
That does not. Not in the Manual J procedure, no.
And then on the, last question about other items that affect it. These low load homes, a lot of them are going net zero. So they're putting on solar PV, solar panels. Is there any impact one way or another, or within Manual J for solar on homes?
Right. So that's a good question. And manual J is silent on all types of external shading like this. So we've got a solar panel on the roof. Now we have the sun's not striking some area of the roof, and therefore we're reducing the heat gain through the roof. And just like with trees, manual J doesn't say if I've got a lot of trees around my house or maybe on the west side of the house, how do I factor that in to the heat loss, heat gain? So manual J is silent on that, and it's the same for the solar panels that might be mounted on the roof. For a quick anecdote, I always thought that was kind of odd until, again, Northern Virginia, we had a weather anomaly called a Derecho, or I've heard it pronounced in a lot of different ways, but that's the way I'm going to pronounce it, a Derecho. It's a big windstorm, very strong winds for a sustained period of time. And after that happened, my neighbor, who lives behind me to the southwest, who had all these lovely big oak trees, the next weekend they were all coming down. He got spooked, and he did not want any of those crashing in on his home. I don't know if there's a collective groan going up out there in the community or not, but you know, it's hard to see a big oak come down just because someone's worried about the impact on their house. But I can tell you that I lost a lot of shade, a lot of summertime shade that was on my roof went away. And so after that, I begrudgingly acknowledge the fact that there are instances when trees come down, and so manual J is silent on that.
And someone just mentioned, though, it does impact shading on windows, just not the walls and roof, correct?
Correct, yeah. Typically, we're not changing the eave on the house. So yes, you're right. Very good point. And so it does, we do account for shading on windows, yes.
Well, we're at our time here, but we have a lot of questions pouring in, and I want to get through one more thing, and then Wes, can you stick around for more questions?
I can stick around for a few more minutes, yeah.
Okay, great. So just real quick, the LEED for Home, or the green building programs and sizing and how that all impacts everything. What we look at are manual J's and sizing being required for programs like LEED for Homes, Passive House, Enterprise Green Communities, and the National Green Building Standard, which I forgot to mention here. And then honing in on LEED, you will find the sizing details now buried within the prerequisite called minimum energy performance, whether you're looking at V4 or V4.1, whether you're looking at single family, multifamily, or mid-rise. It's buried in there under Section 1, complete all mandatory measures for the Energy Star home. So if you weren't seeing that, you might have missed. It's not as glaringly obvious about sizing like it used to be under 2008. So what LEED is referencing and what I shared with you all is the HVAC design report, which has a lot of stuff in it and does need to be completed by the HVAC contractor. And then boiling down here to Section 4, heating, cooling, and equipment, that's where it specifically is going to call out exactly where and when you need to do your sizing depending on what climate you're in, or whether you have single speed, 2-speed, or variable speed, whether you have a gas furnace or dual fuel system or all electric. All those different variables will impact what you need to do. And then down below at the bottom here is a sort of a line item that we pull out from the footnotes. And this is basically where EPA Energy Star attempts to define their terminology for a low load home, and then tell you what you need to do when you find yourself in that situation. So I guess, Wes, I don't know if you had anything more to add to being successful with using this, and then also whether their definition of low load kind of falls in place with ACCA's definition.
Sure, that's a good point. and I'm glad to see them plug this in. I think this is their adaptation of what the manual calls for. The one thing as I read through this that I don't see is that the ACA manual speaks to is a need for supplemental dehumidification or ancillary dehumidification. If that's the one aspect that LLH calls for, if you want to use the excess or the bonus sizing tolerance. So LLH says if you provide that dehumidification, then you're creating a situation where humidity is not as big a concern, and therefore it provides a buffer of 6,000 BTUs over the load, between the load and the capacity of the equipment. So if I've got a 1.5 ton system putting out 16,000 BTUs, or removing 16,000 BTUs of cooling, and my load is about 11,000, 10,000, I've got, and I put in the ancillary dehumidification, then I could put in that 1.5 ton system, even though it's way oversized for a 10,000 BTU load. I think it ought to be understood that there are going to be some cycling issues. There may be some comfort issues, but for meeting a sizing tolerance, that is compatible with the guidance in manual LLH. And that seems to be replicated here as far as the relationship between the cooling load and the cooling capacity. It just doesn't mention the need for ancillary dehumidification.
So basically you're saying, have that dehumidification. You don't have to be so worried about the
right
the load being oversized, correct?
Right, having that excess capacity. It is climate dependent. I mean, if you're in Arizona or parts of Arizona, that's a different situation than if you're in Miami, Florida, or Houston, Texas.
How about the definition of low load home and where you all are placing it kind of versus what Energy Star is saying?
Right. So it doesn't say, I've got a 2,000 square foot house with a total cooling load of less than 15,000 BTUs. There's no area reference. They just say, hey, if you're below 15,000 BTUs and you've got equipment, single speed with a total capacity of less than or equal to 20,000, then that's acceptable. And that, if there's supplemental dehumidification, that lines up with what manual LLH's guidance is.
And I think some folks were wondering if you could repeat what those guidance numbers were.
I could, but you have to buy the manual.
Okay, fair enough.
No, the guidance is, I'll read it. For climate zone locations, for cooling only equipment, and for air to air and water to water heat pumps, the oversized limit for type A climate zones, so that's 1A, 2A, 3A, all the way up to 7A, is up to 6,000 BTUs of total cooling capacity when ancillary dehumidification equipment is used. Now, if I'm not using dehumidification, then I'm back to the standard manual S sizing tolerances.
Okay, so those climate condition A is a more warmer to moderate.
Right. Yeah. So if you look at the DOE climate map, you've got the big line. There are two main lines that run vertically, and it's separating humid from dry and marine. So when you get it over on the West Coast, you've got a marine condition. But yeah, that's the climate zone or the A condition.
All right, great. Well, we're just gonna real quick wrap up with one last thing, and then we still do have a few more questions. You still have time to stick around?
I got a few minutes.
All right, great. So just real quick, this session is approved for Passive House Institute US, so make sure to check your email for the self-report on that. And then take that survey that pops up at the end or sent to you through email. If you're somebody who's watching this in the future on demand for the recording, follow the instructions on the USGBC instruction tab to get your session done and take that quiz with an 80% passing rate. If you're watching this on the GHI YouTube, go ahead and click that YouTube link there right underneath the video. And then from there, click down in the comments, click show more. And then on the right, click the link to access the quiz, fill it out, and then submit it. And a huge thanks to all of our members, our board of directors, our volunteers, all of our sponsors, especially Shrinergy for on the go and in your house, mobile, backup solar power, battery systems for not if, but when the grid fails, T-Stud structurally insulated framing systems that save money behind the wall, Mitsubishi all-electric heat pumps that work down in cold climates, and Panasonic ventilation to help meet all your ventilation needs. All right, so I'm gonna look back at some of these comments here and just see what else we have that's very specific to the conversation we're having. And somebody did bring up the point that in order to meet Energy Star and get that certification for any of those green programs, a proper room by room calc must be done one way or another. So thanks for reminding us of that. And let's see what other items were here. Oh yeah, so you take into consideration on Manual J the directions the windows face, but how about the walls?
No, I think that that's a good question. I have to dig into that. I don't think I could answer that flat-footed right here. I think, Brett, let me just run off at the mouth here for just a minute. Solar load on walls is typically not great. It's a lot more temperature difference driven. By the time the solar load gets through an east facing wall, the sun's around on the other side of the house, and by the time it reaches the other side of the house and it starts heating up the west side, it's starting to go down. Same thing with the south facing. So I think an unofficial response to that would be, I don't believe it has enough time to work its way through the wall to be an impact. That's a very unofficial, top of the mind response to that question.
Okay. No, that's fine. So here's two questions I'm going to kind of merge together. First, at just a high level, how does the low load manual differ from just a conventional Manual J? And then somebody had mentioned, so from my understanding, the Manual J will give the loads for the home, factoring in the size and attributes of the envelope. If the home falls under 1,500 square feet per ton of load, it qualifies as a low load home. If it does qualify as a low load home, then you would recommend applying the principles of the LLH manual. Is that correct? And if so, can you explain some of those primary principles?
Great. So let me do the first one first. And LLH doesn't replace Manual J. So it says after you've done your Manual J, you look at this and you think, holy cow, I got a 3,000 square foot house and I've only got 22,000 BTUs of cooling needed for this house. What do I do? How do I, and I'm going to get to the what do I do and why in just a minute. So we're not really replacing Manual J with this manual. We're just saying that once you look up from doing the calculation, you say, great Scott, I've got no heating load, I've got a very, very small heating load or very, very small cooling load. And so that's where Manual LLH picks up and says, okay, in a lot of climates, if I've got a large dwelling and a very small load, I can find a piece of equipment that can deliver the capacity needed. I can find a 2-ton system for that 3,000 square foot house. That's not the problem. The problem is, how do I mix the air? So I've got a distribution system that has a whole lot less air to move through the space to create the turbulence needed to exchange the BTUs. So if that's the problem, how do I solve that? So a lot of what manual LLH does is talk about how do we mix the air in the space so that we create comfort. I can't just dump 3,000 BTUs of cool air into a bedroom and necessarily expect that to dissipate throughout the space and provide the desired cooling. It works a whole lot better when I mix that air and distribute that throughout the space. And so that's one of the things that manual LLH talks about. The other thing is the equipment options. It looks beyond some of the standard products that are available to look at some ancillary strategies, looking at some zoning, some air mixing. What if we took a VRF system and distributed that air throughout the space? There's just some there's some small duct high velocity strategies that are discussed within the book. So that's what manual LLH is doing, is addressing the air mixing issue, and then some strategies using off-the-shelf equipment that can support improved comfort in these low-load homes.
Great, thanks. Another question: is there guidance out there for selecting equipment per manual S when it is an inverter tech and you are not installing auxiliary heat and need to size to the heating load?
Thank you for that little landmine, Brett. So manual S says, here's the equipment sizing tolerance for a heat pump, period. I think this is driven in part by the fact that for a long time, heat pumps were this kind of oddity that I took an air conditioner, tweaked it, and oh look, now I get a little extra heat. And so they're sized based on the cooling capacity, not on the heating capacity, and that's still the case in manual S. I think what you're seeing with LLH is acknowledgement that we can have some supplementary tools for the cooling side, ancillary dehumidification, that allow us to have a little extra capacity to provide a little more heat with that heat pump during the winter months. And so I think there's a migration heading that way. I don't know that we'll see sizing a heat pump based on the heating load until we have the dehumidification question completely solved, and or the unloading of variable speed equipment or VRF systems, so that we're not left out to dry when it comes to the latent load, especially at part load conditions during the summertime. That's a whole lot to say that we just need to make sure we're proceeding cautiously and carefully with the heat pump sizing, because again, it's considered primarily an air conditioner.
Do you now we're starting to see these ERVs or even smart ventilation systems that have integrated heat pumps into them being used as the air distribution system to both heat, cool, and ventilate homes or apartments. And to some degree, they're obviously supplemented with mini splits, but the intent is to reduce the amount of heads. Any discussion with that in the manual about that sort of new approach?
Not to my knowledge, no.
Okay. So the next question is there a point in low load KVH systems with lower CFM where traditional duct design does not work and small diameter ducts should be used? I get pushback from MEPs used to designing 800 CFM system with 300% oversize and pushing against 400 to 600 right size units.
I just want to make sure I'm understanding the question.
I think it's kind of factoring in duct, smaller duct, small diameter, and you know, is that coming into play here?
So are we talking about the fact that typically small duct high velocity systems are moving half the typical airflow. So it's not 400 CFM per ton, it's 200 CFM per ton. Is that what we're talking about, or is it the total airflow for the system? That's where I'm not, I don't want to.
Yeah, maybe they can follow up here with some more information on the question. I'm not really sure either. So
Yeah.
Yeah. And while we're waiting for that, what about typically these low load homes, aren't typically using radiant because it's said that tight homes don't need it. I guess it just depends on the preference. But how does radiant get addressed?
Okay, that's a good one. So radiant, I don't believe is specifically addressed in low load homes. It's other than the extent that and radiant's typically heating. There is some radiant, some cold beam cooling out there, but I don't believe that was an aspect that was of concern to the low load homes folks. Radiant heat is great. So if I've got a big house with a low radiant or a low heating load, and I'm putting in a smaller boiler, and actually that's a good point. I'll have to explore that and get back to you on that one.
And then finally,
I don't want to oversimplify that.
Right. No, that's fine. And finally, is there an inherent oversizing calculation built into Manual J?
So that's a great question. We get it a lot. I think that there's a couple of factors. One is the level of rigor applied to the calculation itself. Am I taking advantage of all the requirements? Am I factoring in internal shading or external bug screen or the overhangs? Am I factoring in the actual infiltration rate or the expected or maybe the code required infiltration rate? What am I using for duct loads? Am I using 12 occupants in a house? It's a 3-bedroom house. So I think there's some room for improvement in that area. But then there's also the calculation itself, and that is, instead of carrying out to the 4th decimal place, we're rounding it off, and when we're rounding, it might be that we're rounding up. And so when you add all those different additive rounding factors, I believe the author says there's between the possibility of the potential for between 10 to or about 10 to 10% oversize. So the 33,000 BTU load might be a little closer to 30,000 BTUs. So that's hopefully an answer that's understandable. It's more in relation to the rounding of the multiple variables that would lead to any inflation in the calculation itself.
Well, we are at our time, Wes. I really appreciate you kind of sitting through this and taking on all these questions. And thanks to ACC for having you out. And just real quick, before we head out, where can people go to find more information and access your low load home resource if they'd like to?
Absolutely. ACCA.org is our website, and we have an online store. If you type in LLH, we'll be sure to get you one.
All right, perfect, Wes. Well, thank you again, and take care, everyone. Have a great rest of your week. Bye.